For each of the following bonds, assign partial charges and draw a bond dipole arrow. When we solve a question like this, what we need to be looking at, just like we do when we look at a bond polarity, is we need to think about electronegativity. So we need to look up the electronegativity values of the two atoms that are bonded together, compare those numbers, and that'll allow us to figure out what the partial charges will be and which direction the bond dipole arrow will point. Okay, so again, you can look up your electronegativity values in your textbook. You can look them up online. And if it's a testing type of situation, they'll always be provided to you, so you don't need to memorize those numbers. We'll look up electronegativity values for this first bond here with a CF bond, and I'll write those down here. We'll look up electronegativity for carbon. That number is 2.5. Electronegativity of fluorine is 4.0. Okay? And then we want to compare those numbers. What it means to have a higher electronegativity is it means that this atom is able to pull electrons towards itself more strongly within the bond than the one with the lower electronegativity. So in the tug of war, since fluorine has a bigger number, it's winning. If it's winning the tug of war and it has more electrons nearby, that means it's going to have a partial negative charge because electrons are negatively charged. And so we can put our partial negative next to fluorine. Since carbon is losing the tug of war, it has less electron density than it needs, right? And so it's going to have a partial positive, right? You have a positive charge when you're missing electrons, okay? For a bond dipole arrow, that arrow points in the direction that the electrons are being pulled within the bond. Okay, so it's going to always point from plus to minus like this, and it's going to be parallel to the bond. Okay, so here are our partial charges. Here is our bond dipole arrow for this bond here. Let's look at the second one now. We need to look up the electronegativity values once again. For nitrogen, that number is 3.0. For hydrogen, the number is 2.1. The atom with the higher electronegativity is the one that's winning the tug of war, so it'll have the partial negative. The other one will have the partial positive. The bond dipole arrow will point from positive to negative. In that case, it's going to point right to left like this. Finally, look at this OS bond. Electronegativity of oxygen is equal to 3.5. Electronegativity of sulfur is 2.5. Oxygen is our electronegative. It gets the partial negative. Sulfur will get the partial positive. The bond dipole arrow points in the direction the electrons are being pulled in the bond, so it's going to point right to left like this, falling from plus to minus.